Hi, this is Randal Schwartz, host of FLOSS Weekly. This week, Simon Phipps joins me. We're going to talk about Drools Planner, which looks like some really cool software that can solve those really, really hard problems. You don't want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for FLOSS Weekly is provided by Cachefly at CACHEFLY.com.
This is FLOSS Weekly with Randal Schwartz and Simon Phipps. Episode 216, recorded June 29th, 2012. Drools Planner. It's time for FLOSS Weekly, the show about free, libre, open source software. I'm your host, Randal Schwartz, Merlin@Stonehenge.com, bringing you each week, or pretty close to each week, the big projects, the small projects, the movers, the shakers, the projects you probably are really familiar with, the projects like maybe today's show that you're not very familiar with, but you want to find out about. So, great show lined up for it, but let's go ahead and bring on our co-host, Simon Phipps. Welcome back to the show.
Thank you very much, Randal, and greetings to you from Southampton here in the United Kingdom, where it's strangely sunny. There is this strange yellow ball in the sky that none of us have seen behind the rain for many days here now.
And down here in Southern California, it's like 85 degrees and 90 degrees today and tomorrow. That's Fahrenheit for you. You're probably going to be confused if you try to convert.
I'm completely confused by that. I've got a calculator here somewhere. Let me just get the calculator. Now, just do it with 80 degree. I think I can do that.
Yeah. So for those of you watching the live stream or listening a day late to the show, we're actually taping on Thursday instead of our normal Wednesday time, and we're up against a very special event for the live network right after this. So we're actually going to have to cut this show just a little short. So if you're wondering why it's only like 49 minutes or so, that's why, because we had to cut it short because we're up against a live event. Anyway, we have a really great guest today. Geoffrey, something like that, Smet, who is working on something called Drools Planner. What a strange name for something. But from what I understand, it's going to take, sorry if you hear a vacuuming noise, there's some construction going on next door here. What it does is it solves really, really hard problems by trying all the different combinations, but not like brute force, but actually using some intelligence about that. And I've done some coding like that, so I'll have to ask Geoffrey about the difference between what I did and what they did. So it sounds, have you had a chance to look at this, Simon?
I looked at the website, and it looks like something that I needed for my job about 15 years ago and didn't have available. We should have been around then. I'm very intrigued by the fact that he claims to be able to solve any NP-complete problem, because my computer science background says that if he's cracked that, he can decrypt any message. So I'm going to be pretty interested to hear what he means by that.
I hadn't thought of that, but I think you're right. You'll have to check that out with him. Anyway, so without further ado, let's see, do I have any other things I have to say? No, I guess not. So without further ado, let's go ahead and bring on our guest. Geoffrey Smet. I don't know if I pronounced that right. Welcome to the show.
Thank you. It's pretty okay.
Pretty close. How do you pronounce it? Let's go with that.
Geoffrey Smet. Okay. But all the English people say Geoffrey, of course, because that's the English way to pronounce it.
Okay, cool. And where are you speaking to us from?
From Belgium, from Europe.
Oh, yeah. Thank you for the last part, because some of the Americans probably don't know where Belgium is. So, yes, except that it's the source of chocolates and things like that. So that's very good. So at the beginning of the show, I gave a sort of overview of what I think Drools Planner is about. But let's go ahead and hear it from you. What is Drools Planner and what problem does it solve?
Well, it's about business resource optimization. So any company or any organization wants to produce services or products. And to do that, they have a limited set of resources, like human resources, like employees, or assets like vehicles and buildings, and time and money, of course, too. And if they optimize that, they can use less resources and produce more services and better services. So that's basically the abstract idea what Planner does. It's a planning engine, and it solves these kinds of problems and optimizes them far better than what is used now in practice, really.
Okay, so I actually have a practical example that I did some genetic algorithm for, which is that one of my friends, Neil Bauman, produces cruises that have conferences on them. There's a limited number of conference rooms. There's a limited number of instructors, and people have preferences about the things they want to see. So I wrote a genetic algorithm to actually try all sorts of combinations and take the best of those and come up with a final schedule. Would Drools Planner be something similar to that?
Yeah, definitely. I actually have some examples, which is the course scheduling example, which schedule courses. It's not directly the same thing, but it schedules courses into rooms and into periods. So it's very related. So you can probably copy paste that one. And I know of a community member which actually used it to schedule conferences, which is exactly I think what the use case you had, or at least very related.
Very good. And so, what's my interface to this? So, how do I describe the problems and the resources and maybe even the constraints?
Well, so Drools Planner is written in pure Java, and you can, first of all, your domain model, it can be completely object-oriented. So you can have domain objects, so like a course, like a period, like a time slot, like maybe the room is in a building, so the room points to a building and so forth. So a very rich domain object model. And then you can describe your constraints on top of that. So, for example, that no teacher should have two courses at the same time. So, no speaker should have two conference talks at the same time in your use case. And things like I want to optimize the number of people that can go to the courses, to the talks that they prefer, and things like that. And you do that. You can do that in several ways. One of them is in plain Java, where you get your solution. So you get a certain solution which Planner finds, and it asks you what is the score for this. And it will always try to optimize the score, of course. So it will try to find a solution with the best score. So that's one way. But another way is to use the Drools rule engine, and that is that's actually far more advanced because it will go much faster. What you do there is you describe your constraints in the Drools rule language, which is also object oriented, and where again you can reuse Java methods, and you basically describe. So if I have a certain talk assigned to a certain room, and I have another talk which is assigned to the same room at the same time, then we have a problem. Then the constraint is broken, and the score is -5, for example, depending on the importance of the talk and so forth, and depending on the other constraints and how you weight the constraints against each other.
Wow. So basically, I have to describe things in text files, but I also have to write Java to make this work, right?
Let me just check. Yeah, well, it's a Java library, so it will be used by any application out there who wants to optimize a planning problem, right? But we do have the Drools Governor toolkit, which is a web application, and there you can actually describe your domain model in a more declarative manner, and you can also describe your constraints there, but you would still need to use at this point in time you would still need some integration code between them, so to pull out those rules and put them in Planner and so forth. We actually have some ideas in that direction already. But the main use case, the main focus right now is really for Java enterprise developers or Java standard developers or even Java mobile developers to be able to use Planner to optimize planning problems.
Okay, and I'm just a little curious about the name. When you submitted the request for this, what the heck is Drools a larger project and this is just a part of it, Drools Planner, or yes. And what's the name about? I don't get the name yet.
Well. First of all, I'm not responsible for the name Drools. That was just there already.
We're not blaming you, don't worry.
But Drools is the name of the rule engine. And people often refer to, it's actually Drools Export, the rule engine now. So Drools is a project created, I think, 10 years ago or something like that, which is a rule engine in Java. And so Drools basically means the rules, but then it's written completely different, of course, with the chalice innuendos. The problem is that the name stuck. It became a brand. Everybody knew Drools was the rule engine in Java, and so it became really, really hard to change it. So at one point, I actually changed it to Jables Rules, and then everybody was saying it was Jables Rules, and So that didn't help either. It was created too much confusion. So in the end, they just went back to Drools, and that's it. And Planner was created on top of that. Planner was originally just one optimization algorithm, and I figured that this optimization algorithm should be combined with a rule engine for score calculation. So that's why Planner started there, and it grew much bigger now with a whole bunch of optimization algorithms, more features and stuff like that, of course, in the last few years.
And so, what's a business rules engine? Just so our audience is up to date with what you're saying.
A business rule engine. A business rule engine is a way to declare your business logic, so you can actually show it more visually. So, for example, let's say you're in a bank and you have something like mortgage approval. Now, in the old days, they used to write this in Java code, right? The problem is that the people who actually understand these rules, the domain experts, they cannot read Java code. So the people who have studied economics for 4 or 5 years on the university, they aren't programmers, and it works both ways. So with the rule engine, you can actually define them in a DRL, which is a much more natural way. You can actually put natural language on top of that. More importantly, you can change them. There are tools to change them at runtime. So, for example, if the business decides today we will give mortgages to any person coming in starting today, they can do that without actually having to redeploy the application. You just change the business rule, say the specifics part which decides when the mortgage is approved or not. We'll put that in the Drools rules, and then we can actually change those at runtime. So you're not going to put all the business logic in there, just the ones you want to change flexibility, where you want flexibility on and readability on.
Now, I was drawn to a line in your website by my pedantic computer science friends, because you say up there that you've got a tool here that can solve any NP complete problem. That sounds like really bad news for encryption. Do you want to explain why you said that?
Oh, okay. First of all, solve is to get a really good solution, not necessarily the optimal solution. Yeah, you might be right indeed. Might be over marketing that a little bit. If you have certain encryption problems, then it's then either you have the solution or you don't. There is no middle ground, right? So for example, if you want, yeah.
Well, I mean, the definition of NP complete is that there isn't a solution for it. So if you can solve NP complete, then you're going to be rich, my son.
Oh yes. But yeah, so.
So this is an approximation. You're what you're doing is you're iteratively using heuristics to produce an optimized estimation of a possible solution, of a possible resolution of the constraints that you're defining.
Yeah. So the point is that. Yeah. So an NP complete problem has the problem that you can't solve it with brute force because the search space is just too big, and any smarter way of brute force also fails because of the same reason. It just takes billions and billions of years. If the problem is not too big, if it's bigger, then it's longer. Now. What you can do is do approximation algorithms, and I have a couple of those. Those are my construction heuristics, so they get a pretty good solution very fast. Problem is that they stop at that point, and usually this is what if programmers need to implement an NP complete problem, this is the kind of algorithms they write. They get a pretty okay solution, but you can actually do much better. And that's by applying another type of heuristics, which is called meta-heuristics on top of them. And in Drools Planner, it implements both of these heuristics. So you just say, start with a construction heuristic, then do a meta-heuristic, and you actually get a much better solution. So,
right.
And this can be quite drastic.
It sounds from that like I've actually got to have a pretty good idea what the computer science mapping of my problem is before I try and use Drools Planner to solve it. Would you say that was the case, or can I just go in, model my data, and let Drools Planner work out how to solve it for me?
Yeah, because the meta-heuristics are the nice thing about these algorithms is that they are very problem independent. They just figure it out themselves. That's why they call it meta-heuristics. The name meta is a bit bad, but it actually means that they are not specific to one use case. They work pretty well on any use case. Now, it is true that depending on the use case, one or another optimization algorithm might actually work better. But to actually find out which one works better for your data sets you normally encounter and for the constraints your problem has today, you actually have to try all of them. That's the hard part. You have to implement all of them, and you have to implement them correctly, which is pretty hard. They're not big, but they're like 100 lines of code. But there's 100,000 different ways to write them sometimes, and then you have to try all of them. So this is not possible in an enterprise environment. Of course, you don't have that time. So what Planner does is it tries to implement as many of them as possible, good, reliable algorithms, unit tested, and so forth. And then it comes with a benchmarker toolkit. So you basically say, this is my problem. You figure it out. You tell me which algorithm I should use with which configuration in production. So here's a bunch of test data sets. Give 10, for example, or 20, or maybe more if I have more. And I give him a bunch of configurations he can try. So he can try, for example, the meta-heuristic tabu search and the meta-heuristic simulate annealing and so forth, together with different constriction heuristics. There's a lot of combinations you can try there. You just give him a whole bunch of CPU power, you say, and whatever one gives me the best score average in, for example, 5 minutes or 5 hours or 1 second, depending on how long your problem will have in production, that's the one I want to use in production. And right. You will get a very nice solution there. You can save quite, for example, if you're driving trucks around and you want to find the shortest route to visit all the stops where the truck needs to stop to deliver goods and so forth, you can save a lot of fuel and you can save a lot of, which is good for your financials and of course for the environment, which is more important, of course.
Right. So you've got a general purpose toolkit here that exploits the fact that all NP complete problems map onto each other. And then you've got your toolkit. Your toolkit adapts to work out which of the optimized solutions is going to work with the data.
It's not. It doesn't use the fact that all NP complete problems are related. Although that's probably the reason why it works. Yeah, the theory. That's probably the theory behind it. But it just But it's just, for example, one of my favorite meta-heuristics is the tabu search algorithm. This is the one I always start with any given problem I got, and I got now 11 examples implemented. Many of which are real examples with real data, sometimes very big data, and tabu search works really well on all of them. It's not the best in all cases, but it works very well on all of them. And actually, if you would go compare this with what a human planner comes up with, especially if they work in teams and as the problem scales out, or you compare this what a normal enterprise Java programmer would come up with if his boss gives him this assignment, please write me the best algorithm you can to solve this, then it's actually much better, because each of these examples are also entered into competitions, and sometimes I'm doing really well, and I'm actually doing well with all of them, but I'm doing some in one of them, for example, was fourth of 5 of I think 83 sendings or something, and these are research competitions. So there's only researchers who there's not only researchers, but mostly researchers joining these competitions, and they write really fast code, but it's not production code, right? It's not domain orientated, not object orientated, not no logging and stuff like that. So it does pretty well. I mean, given that those competition results.
Right. So how did you get into all this? Because I mean, it sounds like you have just a smattering of computer science in your background there. Are you a computer scientist who's been corrupted into commercial programming? Are you a commercial programmer who's taken up computer science as a hobby? What's your background? How did you get into this?
It's definitely the second case. So I started at writing Java programs and working as Java consultant, and then I took a job as a researcher. And there I saw, I got to know, for example, the tabu search algorithm, one of those many meta-heuristic algorithms, and I saw the demonstration about it, and I said, you need to combine this with the rule engine, because I saw a presentation about the rule engine earlier that year, and people of course didn't understand what the rule engine was, and I said, let me just try it out, let me just prove it, and that kind of got out of hand because that's the Drools Planner today. I've been doing Drools Planner since 2006, and mostly in my spare time. The last few years, I'm working for Red Hat, and I get some time from Red Hat to work on it too. And it just grew bigger and bigger, and I learned more and more about these kind of problems. But I am still focused. My main concern is not to find the fastest algorithm, although I would like to find that, of course. But main concern is still writing something that is very usable for normal Java programmers. So very easy to use for normal Java programmers, and just comes with everything you want from it. So POM metadata, logging, and so forth, unit tests, coverage, and flexibility, and so forth.
Right. So who else in the community is there in the community apart from you? Are there other computer scientists, or is your community more commercially focused?
It's more commercially focused. There are a couple of people. So basically, I get pull requests on GitHub, of course, for features, mostly for bug fixes, actually, some features. And these are all people who are need to solve this problem now for an enterprise problem. I have a couple of researchers watching me, and I'm actually watching them more, which do really nice work. But they just like to write their own programs, right? They just write such an algorithm from scratch in one class file or something, and they do really good work. They're really smart algorithms they write, but it's just something you would never in a million years put into production, because it's research focused, not production focused. Right.
And so I see this is Apache licensed. Do you have any kind of community governance around this, or are you purely using Git as your community governance?
Oh no, we're part of the jboss.org community. So we have actually, first of all, we're part of the Drools JBPM community, which is part of the jboss.org community. So we got an IRC channel on Freenode, the Drools IRC channel. We got user mailing lists. We got Jira. We got there's a full manual, of course, for Planner. We just use GitHub for source code, because Git is really just so nice. One of the best things we ever did. Switch to it.
Well, it solves lots of governance problems. I've been watching lots of projects adopting it, and the way that it uses pull requests to get contributions so simplifies the idea of getting contributors involved that it really smooths things out. So you're using GitHub. You haven't decided to host something on jboss.org.
There is something on jboss.org. There is the main homepage, the one which shows, which explains what it is. All our downloads are from jboss.org, and all our so we have counters of downloads counters and so forth there, and all our and the complete manual is on jboss.org too, of course, which is getting pretty big right now. It's 11 chapters or something.
And it's being pointed out to me that remarkably, FLOSS Weekly has never covered JBoss. So you may want to tell some colleagues that, and maybe shake them out of the tree. But we ought to tell listeners and viewers what JBoss is, that it's a Java application server. But it's more than that, isn't it? It's got lots of other sub-projects in it.
Yeah, it's far more than that. So the JBoss application server is the flagship, of course. It's a full application server following the J2E spec and so forth. That actually. Then we have a whole bunch of other JBoss projects also. A couple of famous ones, like for example, Drools and JBPM, of course. Drools is the rule engine, JBPM is the workflow engine. There is Riftsaw, RestEasy, Archillion, which is a really famous one right now in the Java community. It's for testing. a really nice one. There's Weld, which is a CDI implementation. There's a whole bunch of projects there, and people pick and choose the ones they like, and hopefully run it on JBoss AS, but they often run them on other application servers too. It's all open source, and they pick and choose what they like, of course.
So I'm a programmer who doesn't know Java. I'm sorry about that, but every time I try to get into Java, it just looks like it's the COBOL of programming languages, which is sort of weird because COBOL is a programming language. But I mean, it just seems too verbose for me. But how complex? So I'm just trying to get this whole picture again. So I have resources like slots somewhere, like, these have to eventually be filled with something, and I have things I'm going to put in those slots or some sort of actions that I'm going to do against those. How complex can the conditions be? Can they be arbitrary complex code? Like this resource can only go in this slot if the slot ahead of it has these 3 things in it, that sort of thing?
Yeah, definitely. You can. You could even call a remote service, but it's a really bad idea to do so. But you could call a remote service, really, because he's going to normally have like 2,000, 5,000 scores calculated per second. So if you're going to call a remote service, that's not going to be that number at all. But you can also call Java code. Of course, if it's Java score calculator, it's natural you can Java code, but even if you use the Drools one, you can just call Java code. For example, something like, is this a holiday? And you have to give the country of the person as a parameter to that method, because the holiday actually changes. For example, in a week, I won't have a national holiday, but I presume you guys will. That's all possible. And the nice thing is that even if you use the Drools rule engine for the score calculation, it does incremental score calculation. So when you have a big solution and you change 2 things, it calculates the delta of the score and not the entire score all over again. And that's a huge performance gain, especially if you do that 5,000 times per second or more.
Yes, I'm just trying to imagine how this works. It must start by, I mean, you're obviously going to be able to tell me much better than I can just guess, but my thinking is that it sort of just tries something and then comes up with a number for it, like this is a plus 38, and then it tries another thing by moving a few of the things around, and then it comes up with a plus 45 and goes, aha, better. But can you describe it better? Obviously, you can describe it better than that, but without getting too complex, how is this thing actually making it better?
Okay, so first of all, you need to know there are 2 phases, really. First is the construction phase, and then is the meta-heuristic phase. So let's take the conference scheduling example. So the construction phase says, let's take all the talks that we need to assign a room and a period, and let's order them by decreasing difficulty. And if you don't know them, we just take an arbitrary order. So decreasing difficulty means we'll take the talks which most people like, which most people want to see. We'll try to schedule them first. And then you order those talks in that order. You take the first one and you assign it to the best possible room and the best possible period for that talk. You might have multiple, then you just take a random one of them. Then you take the second talk, and the second talk you assign it to the best remaining room and the best remaining period. So because of the first one is assigned, that might actually have influence into the one you can assign the second one to. And you can keep doing that until you've assigned all the rooms. And that's basically construction heuristics. So, and that works very fast, but that's not optimal, because the optimal solution, so for example, you might choose to put your first talk into room 1, because you don't know if I should pick room 1 or you just take the first room available. And it turns out that the optimal solution doesn't have it there. So what the meta-heuristics then does is it takes the solution from this construction heuristic and it basically starts swapping things around. That's the simple way of explaining it. It basically tries if I switch the room and period of this room of this talk with the room and period of another talk, and then I just and see if that's a better solution. I'll take that. If it's not a better solution, then I won't take that. That's the simple way. But that's the hill climbing algorithm. That works pretty well for about a few seconds, and then it gets stuck, and it doesn't improve anymore. And the other algorithms have ways to not get stuck and keep improving and so forth. But you do see that the first few seconds, the gain you get is more, of course, is far higher. And then if you give it more and more time, it actually flattens out as the score actually improves. At some point, it stops improving, of course, because you might have reached the optimal solution. But the point is that you can actually go a lot further than what you get with the construction heuristic, which is what basically most human planners. This is usually the quality that they give, although they don't have the capacity to calculate all those combinations if the problem gets big, of course.
Now, you said you were entering competitions, and what does this compete with, and what are these competitions about?
Well, with other researchers. So what they do is the research community, the academic community, is they for example, the last interesting one is the Google RoDev competition, where they basically say we have a bunch of processes and we have a bunch of machines, and we need to assign those processes to those machines. And we need to make sure that they have a whole bunch of constraints, because processes belong to a service, and the service should never be down, even if the building of the machine breaks down. So they have really complex constraints and so forth. Not that complex, but they have pretty okay constraints. They have a whole bunch of resources. So the main problem is to make sure that every machine has enough CPU for all of its processes, enough RAM for all of its processes, and so forth. They actually have 12 of these. So CPU, RAM, network bandwidth, and 9 others or something like that in some cases. There's actually a prize for the winner. Now, a lot of academic researchers join these competitions, and they try to basically find the best one. And of course, the one who finds who actually has the best algorithm wins. Now, the cool thing what they do is they actually give you a bunch of data sets, and a little bit later they give you a bunch more, and they hide a few data sets. So you could. And they give you 5 minutes on their computer, on a standard computer. So every contestant gets 5 minutes for each of his test data set, for each test data set on that computer in the final round. And they just take the one which has the best solution on average for all the data sets, including the ones they never gave to us. So we don't know, because you don't know which it's in production. You don't know which data set you run into, right? So it's also impossible to decide in advance.
Now, what you just said there sounds to me like, I don't know if you're familiar with this or if you even tried it with Drools Planner, but there was a competition that Netflix set up to try to get the best matching movie selections based on the previous history and future stuff. Is that something that Drools could be used for? Are you familiar first with that contest, and would that be good for Drools?
Yeah, it would be good for Planner, I think. With, of course, the rules engine for score calculation below. One thing I wonder, is there any need for probability in there? No, predictability. Sorry, not probability, but predictability. So where you're going to say, I'm going to have to somehow predict what the user will view next.
Yeah, that's basically it. So given a history of these movies they watched and other people that watch similar movies, can you predict of this following set which they would rather see?
Then it's not a problem for Drools Planner. Drools Planner is about it's not that you can't use it for Planner. But what you can do is, once you can predict that, then you still probably want to optimize which movies you're going to show to them when, and then you have a Drools Planner problem. So it will be nice when there's some experiments going on the Drools rule engine with probability. I'm not sure about predictability yet, but if they develop a syntax and a way to express this more easily than you would have to do now, because this is very hard to do that, to implement it, then Planner would be able to reuse that. So that would be nice if somebody in the open source community does it, of course. But it's not a small task.
Right. So now one of the questions that came up on the IRC chat was whether you've ever considered a front end for Drools Planner that doesn't require programming skills, like maybe a spreadsheet or a plugin for LibreOffice so that you can use LibreOffice spreadsheet to deliver data to Drools Planner. Have you ever considered that? Do you have any plans for it?
I don't have any plans for it. I definitely consider it. It's a very good idea, but time is very limited, and I'm focusing solely on the core planner engine at this point. So if anybody wants to try that and wants to contribute that or actually start a project like that, it's very welcome. What we do have is we have the Governor, which Governor is a web application to manage Drools really, and you can define your Drools rules in there. So there is an opportunity there to define your score constraints, which are actually the rules in there with, for example, decision tables, which is very spreadsheet-like. So you could say, so there's definitely opportunity there. We just don't have any good examples yet. We might need a little bit of integration here, and there. But that's definitely something that will come. But the future we'll see about the future when exactly that will come. Of course, there's a million other things I'd like to add, of course, and I'm focusing really on the engine myself at this point.
Right. And so this is all in Java, so presumably it would be possible to pick this up and use it for an application on Android for mobile use?
Yeah, I know of one current bug or something in Drools that you cannot run it on Android, but there's actually that will be fixed sooner or later, definitely. But you can actually use plain old Java score calculation, and then you don't use rules, and then I'm pretty sure it should run on Android. I've actually the other day I've deployed a planner application on OpenShift, which ran without a problem. Of course, it's not a mobile device. So OpenShift is Red Hat's cloud service, but it just deployed and it ran there without a problem, without any modification. So I'm hoping that for Android it will be the same thing, and it's on my to-do list to actually try that, and I'd like to try that real soon, because I would like, if I can get this on a tablet, and then I can really show people that I can challenge people. Can you do better than the computer? Basically, you give them a traveling salesman problem or a vehicle routing problem. You say, okay, click in which order the truck should drive, and you get a scan, find the best one, and then planner tries, and then in a few seconds he should easily do better than what a human does. Of course, except of course it's a toy problem with only 3 or 4 cities. But if it gets bigger, of course.
Now, do you think you've got anyone in the community who's likely to be pushing these boundaries back, or have we got to go look for them for you? I mean, how many people do you have in the community? How many core committers?
On Planner itself, I'm the only one who is actually really actively every week, every Friday I work on it for Red Hat, and every Saturday or Sunday I also work on it. There are a bunch of people who have, like Lukasz, who has done quite some contributions in the weekends, but for Planner itself, it's just me. But the Drools JBPM team is pretty big. There we are with, so for the Drools rule engine, for example, I think there are, no idea, 6, 7, 8 people employed by Red Hat, and then a whole bunch of more in the community. So there's a big community there. And so anything relates to score calculation, if they improve, as every release, Drools gets faster, and as they get faster, Planner gets faster, even though that doesn't have to be changed in Planner just to get faster. It just profits from the improvements in the rules. But we'll see how Planner develops, of course. If it's productized and so forth, then we will hope then might actually be more people working on it. We'll see what happens there.
So, I mean, you've been doing this since you said 2006. How do you, and you're working on it 8 days a week by the sound of things. How do you keep going? You must really love it.
Yeah, first of all, it's a real passion, and in the first few years, I didn't work every week on it. There were sometimes 6 months or 8 months where I didn't change anything really. So, yeah, I'm really addicted to the last few years. It's just, it's basically competitions which make it so much fun. You know, you want to win, and you know, if I just implement this extra feature and this improvement, then I will get an even better solution and so forth. So that they really drive me. But it's also just see how it develops. The more and more companies are using it for all kinds of stuff, and it's just great that it's been used in the community, of course, improving, hopefully saving the environment a lot, because if they use it for vehicle routing and things like that, they use much less fuel. I'm actually.
Go ahead. Sorry.
I'm a bit sad that I can't demonstrate the examples, because they make so much clearer. You can actually visually see how it improves. So if you download the zip and you just run the run example script and a shell script or a batch script, it pops up and you can actually try each of the examples and see how they improve.
Well, we'll have the URL in the show notes, of course, always, as we do for this. I just got to say, as a fellow programmer, I completely relate to the idea of just wanting to keep working with something because it's cool, because it does something that you can't do by hand and way too complex, and it solves really cool problems. I like stuff like that. Like, I don't know, it's like I'm fascinated by Sudoku solvers, just because it's like, well, how do they figure out how to put all those numbers in there without just using brute force? So, oh, this could do Sudoku, wouldn't it? Really well, right?
Yeah, it's just fun, and you see how you implement, how it's easy it is when a new competition starts to just take the just write the domain model and constraints up, and you're done, and the algorithms just work on them, and you play with it with the benchmarker to see which one works best, and in no time I have a pretty good solution already. So it's addictive. Yeah, there's a certain sacrifice, because I would like to contribute to much more other open source projects. There are really interesting ones, and you just know I cannot even start to that because I might get distracted, and so it's yeah. And also, of course, yeah, I'm married, so I need to make sure that I don't work the entire weekend on Planner, just one day a weekend, and because I love my wife, of course, and needs to be well. So there's a balance with your life, of course, and yeah, that's sometimes hard, but it's definitely worth it.
Now, I'm curious, at what age did you start being a programmer?
Actually, quite late. I think I was I'm a little bit older than I look. I'm 30 now. So okay. And I started at 18, I think. Yeah.
Wow, it is late for someone who has a passion about programming. That is actually pretty late.
Yeah. Yeah, but from day one, I wrote applets to begin with, so visual effects and stuff like that, and then yeah, it's just fun trying to do better and better.
Well, we're almost out of time, unfortunately. This has to be a slightly shorter show than average. I'll explain that in the opening. I explained that in the opening, let me put it that way. But is there anything that you want us to... damn, time gets in my way. Is there anything that we haven't talked about that you want to make sure our audience is aware of about this project?
Not sure. Let me just think. No. Just take a look at the manual or download the zip and try it out yourself. And don't, yeah, one thing is important. Don't presume if you have really smart human planners in a company that they actually do a very good job, because they do a very good job. Because if you compare them, because as a other human looks at this and they say, okay, there's no way I can improve this solution. But then if you then actually try these kind of algorithms on top of them, then all of a sudden you have a better solution, which is radically different, of course, from the one they bring, but which is actually a much higher score. So definitely take a look at that, because they can save quite you can save quite some resources there. And you still need the human planners though, because they are the ones who know how the score should work. They are the ones who can define that. They are the ones who can also tweak it as it gets better, as it evolves, and who can watch that it actually does the right thing and so forth. It will do the right thing. That's not the problem. But sometimes there are ironic things happening. So they get a better solution than the human planners. right? And the human planners take quite some time for this, hours sometimes. And the machine does this in fewer time, or takes as much time as it gets, really. And then the human planners look at it, and they can sometimes actually improve upon that, which is quite embarrassing for the algorithm. But there are ways to deal with that.
Definitely. And Simon just whispered in my ear, I don't know what this means at all, so I'm not a Java programmer, but Eclipse or NetBeans?
IntelliJ. No.
That still exists. Oh, okay.
Oh, is that the editor question? Is that what that is?
Yeah, that was your editor question, Randal. That was you can ask via Emacs. I don't mind.
I'm not going to ask that because he's working with Java, so I know it's not going to be either of those. So thank you, Simon, for that question. And you said IntelliJ, which I presume is even another editor that people use with Java, right?
Yeah, and it's the religious question, of course. Which editor do you presume? All of them are good. All of them work with Planner, of course. But I'm a religious fanatic of IntelliJ because that just listens to me and understands what I need to do, and the others don't.
Sounds wonderful. Well, Geoffrey, now that I know how to pronounce your name, thank you for coming on the show and talking about Drools Planner. Really fun chatting with you.
Thank you. Thank you for having me.
Very good. Very good. That was Geoffrey de Smet. Talking to us about Drools Planner, which now we know the origin of the name and what it all does. Simon, what'd you think?
I think it's awesome stuff. You know, I remember a couple of times back when I was programming stuff up back in those dark days many years ago, looking for a way to do scheduling of rooms and scheduling of calendars and scheduling of jobs, and finding there were no libraries out there that could really help me with it, and that I was programming it up from Art of Programming. And so I find this actually really exciting, and I want to go play with it. I particularly would love to try and work out how to get it as an add-on to LibreOffice so that you can use a spreadsheet to do things like classroom planning and vacation planning. What about you, Randal?
Well, yeah, wouldn't that be great to just go into the LibreOffice and make up a spreadsheet, and one of the function calls was compute the score, or compute the best solution for this, and you just drop that in another cell and you're done.
Yep. Yeah, I'd love to see that. So that would be great. So I'm excited by this, and I'm definitely going to go look into it some more.
Yeah, and I am too. It's like, now I want to go out and find problems that I can go solve this with. Of course, programming in Java. But anyway, whatever. As your question, as you asked, was what, is there a way to get at this without programming? But I understand the need for expressing rules in a language, and hey, Java's nearby, so they're using it, of course, which makes sense. So yeah, I'm excited by this. Pretty fun stuff. And Geoffrey did a really great job describing it and responding to our crazy questions for that. Speaking of that, we have some upcoming guests. I've been busy scheduling Q3. I've got a bunch of emails still flying out, waiting for some responses back. But a couple more people added to the list. We do have coming up, not next week, because next week is the 4th of July. And so, well, my show taping would normally be the 4th of July. So the Brick House is closed. So we're not doing a show next week. So don't tune in next week. Well, you can tune in, but you're not going to hear anything. But the following week, we're on our new 8:30 a.m. Pacific time schedule. So if you're a live viewer, as many people are, you'll have to remember to get up an hour earlier, because we're getting up an hour earlier and taping the show a little bit earlier. That's so they can have a 10 o'clock slot across the week to do TNT. So anyway, on that show, we are going to cover, what are we covering? Oops, a Scalar. There we go. Look at my notes. Where's my notes? There. Scalar Cloud Manager. So it's yet another project. We have to go back to the cloud finally again. I know you guys were missing the clouds because we hadn't done it for a couple of weeks, but now we're going back to the cloud again. So Scalar, it's a manager for setting up cloud software and stuff. Most of what I know about. The following week, Simon and I, you and I, are going to be at OSCON, and we're going to try to get a live show out of there again at 8:30 in the morning. It'll be early. Actually, it'll be ahead of the keynote, so it might be easier actually to find people for Wednesday. A few weeks after that, we're going to talk about the Falcon programming language. I looked at this thing. It's really sort of amazing. It's a cross metaphor language. So it's got some object programming. It's got functional programming. It works well embedded. It's really kind of interesting, brought to me by a viewer. And then a couple weeks after that, we've got the Open Bravo ERP system, which should be a lot of fun. One of those enterprise sort of thingies. And finally, I've been trying to get this project on for years. The Twisted framework for Python. This is basically a sort of a net management thing, so you can have simultaneous many events going on, and it dispatches the proper event, and you can build web servers out of it and all sorts of wonderful things like that. So those are the ones that are planned. We still have some open slots that are being filled as we speak. If you follow us at Floss Weekly on Google Plus or Floss Weekly, all one word, on Identica or Twitter, you'll hear us as I schedule these people in. Again, a reminder, we're moving to 8:30 starting July 11th. We have a live chat room. We've took a couple questions from that here. It's at live.twit.tv at the time that we're taping. You can also follow me personally, Merlin, Merlyn, on Twitter and Identica, although I don't say much on Identica, mostly Twitter. And but my main way of communicating these days is Google+. So Randal L. Schwartz on Google+. Go search for me there. Again, I'm coming up soon. I'm going to be with Simon at OSCON in the week of July 16th to 20th. And I'm going to be in Porto Alegre the week immediately following that for FISLE, the big open source conference here, probably I think my 7th time there or 8th time there. Speaking, actually doing my 2-hour presentation on Git and then just hanging out and drinking caipirinhas. I'll be in Rio the following week to meet with Rio Pearlmongers. So if you're in the Rio area, again, watch my tweet handles. You can see all tweet handles. Or watch the handle. Just watch what I say on that handle. You'll be able to tell where I'm going to be. That's enough plugging for me. Simon, where are you going to be, and how do we find out more about you?
My life is much simpler than yours, Randal. People can track me very easily by going to webmink.com. That's webmink.com, where I aggregate all the stuff that I'm writing on InfoWorld, on Computer World. I've got a white paper coming out for OSCON that I'll link from up there. And then I'm going over to OSCON. I'll be hopefully doing some speaking engagements in the Bay Area around that. I'll be going to the Community Leadership Summit in Portland before OSCON. OSI, the Open Source Initiative, have got some very exciting news that will be breaking at OSCON that gives all of you, the listeners and viewers to Floss Weekly, the opportunity for the first time to become members of the Open Source Initiative. And we hope that you're all going to want to join in with that. There'll be news of that live on the show on the 18th of July. And then after that, it's just all turtles all the way down after that, Randal.
Very cool, very cool. I don't know if you hear it on the mic, but it's a little noisy here. Apparently there's some construction next door to me, so ignore that, please. It's not actually happening. It's not actually hearing it. Oh, Simon, once again, a pleasure to have you on the show and chatting with us and chatting with my guests. So thanks again for joining me.
It's been great, and enjoy your trip.
Absolutely. Thank you, Simon. And as always, we'll see you again next week on Floss Weekly.